Okay. There we go. Let's go. So, this week, the plan is on Tuesday. Today we're going to go over what used to be Lab 5. What used to be Lab 5. Let me publish that. Okay. I'm going to go over what used to be Lab 5, and then on Thursday, I had listed to do the leap year exercise, but I'll wait for that for next week. Once we start doing the exam, Thursday I'll be doing I'll be going over the practice exam. Okay, so that's the plan. Again, so your exam will be given out in lab. The exams will be the same except for the most minor of modifications, to make sure that I can make sure that everybody gets it, so that it accounts for people taking it at different times, But overall, the practice exam does give you a very good representation of what you'll be seeing. So, today we're going to work on some problems that I used to do as homework. These are checked for completion, not for correctness, so there's no need to demo them. They are count as in-class stuff. If I see that you've uploaded something that looks vaguely like an attempt on this, I will give you full credit. Okay, so if you're watching this later, so this used to be homework, this used to be the second homework I would give on loops, until I realized, oh no, I like the one I want to do more on turtles, and I made the lab 4 longer, okay, so they could accommodate for this. Part of this was because today also gives me the chance to kind of talk about printing versus returning for functions. You don't need to know about returning for the exam. That if you've checked the exam problems, it doesn't really tell you to return anything, because most of the functions on the exam, they do one of two. The function on the exam, they do one of two things. They print out something, right? Or they make a turtle move, so no returning needed. Okay. So, and then there's a disclaimer there. Remember, if the problem asks you to return something, you don't print it out inside the function. You print out where the function was called and return the value. So the point being is that basically we've been previously using one method of getting data back from a program, and that was to basically print it out for me, the user. But the computer can't really reuse that information. When you print something out, that's it. It's just printed out. You can't really do anything with it other than look at it. And when I mean you, the user / programmer. What we do is that we use, the return function. Now the return keyword. What the return keyword does is that it gives back a value so that it can be used in another function. Okay? So let's go ahead and see. Number of vowels. Write a function which, given a string, returns the total number of vowels that were in the string. That means you need to feed the function, you write a string as a parameter, and return an integer. So this will require a few tools, right? So this week's stuff, we're going over the for loop and Boolean expressions. So that introduces us to the if statement, which is going to be fairly straightforward, because for this one, we don't need anything more advanced than, normally in other programming languages, you'd be using equal to, or greater than, or less than. But for Python, we get to start out early, nice and easy, and use a keyword we've already been using. We just use it as a question, which is in. We ask if something is in something else, right? So, for instance, what do I mean by that? You can ask Python, you can use Python to ask some questions that are true false in nature. For instance, I can ask 5 in, sorry, not on, in 1, 5, 7, 2, 4, right? I've got a list here. Let's actually save this as, 5. I'll copy this so I can replace it. 5 in 1, 5, 7, 2, 4. Right, I've got a list here. I'm asking Python, is 5 in this? True. Right? Let's go ahead and save this so I don't have to keep copying and pasting it. So if I can ask 5, and if I ask 9 in L, L being this list, well, it doesn't have 9 in it, so we'll say false. So this is a question we can ask. Okay? We can now. So this is a very powerful tool. You can let it be a variable. X is equal to 5. X in L. True, right? Is 5 in L. Variables can be on both sides of this equation. And it's always the small, is the singular thing in the collection. Right? That's what that means. Okay? The last thing of note is, once again, if it works on lists, it works on strings in the exact same way, right? P in apple. True, right? E in apple. That's also true. Let's go ahead and, and now F. The letter F, right? That's why it's a string. In apple. False. Okay? So what we do here for this first problem is, and I'm going to be working in idle today, so is that we're writing a bunch of functions. So the first question asked me, just to refresh your memory, was, hey, write a function which, given a string, returns the total number of vowels that were in a string. That means you need to feed the function you write a string as a parameter and return an integer, right? What does that mean? So first off, most functions, when we start off writing them, we should write them like this. So to write a function, we do def, and then the function name. Here, we want to count the number of vowels, so I call it num vowels. And then the functions look like this. Basically, do stuff, do other stuff, and then we're done with it. Right? Don't actually type this. This is error. What a function is that if we think of a programming language as a literal language, okay, for a second, then all a function is the ability to add our own verbs to this language, okay? So we have the ability, so we've kind of had the ability to kind of name nouns, right? We could give names to integers, we could give variable, right? We could create variables. We would give names to integers, names to floats, names to doubles. The entirety of Computer Science 2 is called object-oriented programming, which means it's dedicated to nouns in programming languages and just working with nouns in programming languages. Okay. Here, though, every programming language has the ability to make functions, which are essentially our verbs. You can think of them as mathematical functions, just stronger, in the sense that, like, you could make a function that does this, right? Let's go ahead and comment this out so that will run, right? Hopefully you've watched the videos on this or done the exercises in the book, but if you haven't, that's why I do this multiple approach, because I know that this is where the first semester gets crazy. This is the time when you start getting all your exams, okay? So def f, right? F of x. Hey, that looks familiar, right? Right? Return 2 times x. This is a very simple linear function, as we call it, okay? And just doing this doesn't do anything, right? We run it, go ahead and put it on desktop, and we're just going to, come on, desktop, and we're going to call it functions fun, because why not? Okay, and just running it does nothing because we just simply defined the function. We didn't like use it or anything. That's why it's not doing anything here. Similarly, calling it, invoking the function, doesn't do anything unless we actually like use it, right? We have to print it out or something like that, okay? So I could say answer is equal to, so here I'm going to create a variable called answer, and I'm going to say that we're going to put in f of 2. Now, why am I putting in 2 there? Well, it's not so much why I'm putting the 2 in there as that I'm putting a number or something in there. What this function does is that up here is kind of the signature of it. You have the name, open parentheses to start it, and then you have what? You have a list of variables. A function that's very complex might have x, y, and z in there, right? But for the most part, for a lot of these assignments, we're just going to give it a single variable, right? And basically it's saying I won't be able, basically f is saying here, I can't run unless I have a variable. By coincidence, the variable is named x. You know, it could be whatever I wanted. It could be Fnord, it could be Apple, it could be whatever. Okay, but it's x because I'm making a mathematical function, and that seems right. So this is the input over here. This is defining f is the name, x is the input, return 2 times x is our output. So print answer will print that answer, which is 4, right? What happened here? F2. So what this does is that this takes 2 and it copies it into this function. It says, I'm going to take this 2, copy it into here, and anywhere I see an x in here, I'm going to replace it with a 2. So it does, okay, 2 times x, well, x is 2, so 2 times 2. If I did 10, which is, again, I'm trying to keep the math very simple here, right? Multiplying by 10 is very easy. So this would copy 10 in for x, it would see 10, right? And then it would do 2 times 10, which would give us 20 back. Okay, now one of the things that Python does not have, at least in this class, is guardrails. Now other programming languages have guardrails. What do I mean by that? Well, this is a mathematical function, so why don't I put an apple there? Just because I can. Why not? And, aha, apple, apple. Probably not what we intended, right? Or, you know, so basically, though, in other programming languages, it will say, okay, it will define that its input x has to be an integer or it has to be a float. Okay, here, I can put in whatever I needed, whatever I want, and as long as it's going to be validly interpreted, Python can do it. Right? If I suddenly made this 2 plus x, and I put in apple, suddenly we're in a world of hurt, because we're going to try to add 2 to apple, which is going to say, hey, you cannot add together an integer and a string, right? Here, again, and whereas if I put in 10 again, we're going to put in 12. And the reason we do these things is because these functions are easy to copy and paste from one program to another. They're easy to reuse. What we're writing right now is one that you might write a few times, which is number of vowels. It's a function that says given a string, okay, so let's go ahead and call it def num of vowels, and it says given a string, meaning I'm going to take in a string as input, okay? What's that string, and let's call it maybe word or text, right? Given some text, what does it want us to do? It wants us to return, whoops, sorry, give me a second. I'm going to zoom in. I got to zoom in the proper way, apparently. Return the total number of vowels that were in the string. That means you need to feed the function, you write a string as a parameter and return an integer, right? So here we're going to give this a string, and it's going to tell me how many vowels are in it. So what this is going to need to do, how this is going to work is that we're going to need to count the number of vowels, right? Okay? So we can say maybe total is equal to 0. And then what we'll do is that, so this will be our answer. I always like to do this when I'm writing functions. Figure out what my answer, what's going to hold the answer. Not what the answer is going to be per se, but what like the answer's, what we're going to say is the answer, right? Which is return total. That way I know it's going to run, and at least if I give it a call, like if I say, hey, hey, how many vowels are in, let's go ahead and comment this out. Comment these out. How many vowels are in apple? Now, there's two vowels, the A and the E, right? But if I ask it that, it's going to say 0 right now. Why? Because that's all it literally does. It says total is equal to 0, return total. But I've got an answer. It doesn't crash. It's the wrong answer, but I'm getting an answer, right, which is always a good first step, even if it's the wrong answer. Getting something down helps. Okay? Yes? Oh, yes, I could. That is an excellent question. So the question that was asked was, can I use this variable in a can I use the word total in a different function? Yes, that is the answer is yes. The idea here is that functions have something called scope. Okay, so let's go ahead and see if this, now this always confuses me with Python because it always seems to work a little bit differently. There we go. So here I asked it to count the number of vowels in apple, which it does incorrectly. It gives me a 0. And then it tells me, hey, on line print total, I get an error. It says name total is not defined. So the idea here is that we have something called scope. The idea here is that what's created inside a function essentially stays inside a function. The variables only exist for the scope that they're in. So So total gets created here, and once the function's done, total no longer exists. Yes? What if I put total out there? Excellent question. Total is equal to 5. This is one of those things that is terrible, I think, that will happen. Yep. Total is equal to 5. Def num vowels. We set total equals equal to 0, return total, which is 0, and then we print out total, which is 5. So what's going on here? We have two separate totals. That's what's going on here. What's inside the function stays inside the function. This is actually standard in programming because programs get big and you cannot remember what was outside of every function, what was in other functions. So simply put, if there's something outside the function and you name it and you name something inside the function, it's going to assume you want to talk about the one inside the function, unless you specifically specify otherwise, which is beyond the scope of this particular lecture. There's ways to do that, but right here, the idea here is that functions are kind of self-contained units that are going to be, that we want to be able to easily copy between one program and another. It was an excellent question. So yes, you can reuse the variable names because, boy, it'd be a pain if you have to remember what variables you've used, right? And you can use them outside of the function as well. Okay. So now, how do we count the number of vowels in this word? So first, before we get into the if statement, we can actually solve this by using what we've learned so far about from last Thursday about different functions and lists. Okay. So this is just a counting question, so we can just count the number of vowels. Now, what I'm going to do here is a bit weird, but let's make a list of all. Actually, before we make a list of vowels, let's go ahead and just do this. What we can do is that we know we can just do something like this. Total is equal to plus equals text dot count A, and we'll go ahead and assume that this is all lowercase, right? And I'm just copying and pasting this 5 times. Why? Because there's 5 vowels, A, E, I, O, U, and So this says count the number of times A appears, count the number of times E appears, I, O, and U, right? And we can run this, and and if you wrote this on an exam, by the way, and I asked you to if you wrote this on an exam, I'd give you full credit, even though this is not the way I want us to work on this problem. But on an exam, what I care about is, did you answer the question in any way, shape, or form, right? Did you address the prompt, okay? Did you try to answer this question? And if you did, and you give me the right answer, I don't care how you got to the right answer, right? Unless I say, use only this, way of doing things, which I generally try not to do, right? I want you to show me what you know and how you know it, and as long as you get to a right answer, or get in the direction of right answer, that's what I care about. So everybody see what's happening here? I'm using the built-in function, A, E, I, O, U, okay? However, suppose the count function didn't exist, right? Suppose that this did not exist, right? In which case, what we need to do is that we need to go through the text for letter in text. Why letter? Because it's easier to spell than glyph. Or a character. So for each character in text, right? So we're going to go through every letter of the text, and I want to ask a question. If it's a vowel, I want to increase total by 1. And if it's not a vowel, I'm not going to do anything. So there's no kind of or else. Just if it's a vowel, do something. Okay? Return total. Okay? So what we can do here is we can say is that we'll use our if statement. We're going to start asking our question, which we're going to ask if letter equal A. Now, a lot going on in this sentence, right? If letter is equal to A. For every letter in the text, if the letter is equal A. So we have two equal operators in Python and in other programming language. We have the equal operator, which is the assignment operator, right? Take the thing on the right, put it in, and store it in the left. And then we have this fat equals, so to speak, the double equals, okay? And that is from, and why double equals? Well, because we get it from these operators, of course. The greater than, the less than, the greater than or equal to, the less than or equal to, or the just straight up equal to, right? These are comparison operators, right? Greater than, less than, greater than or equal to, less than or equal to, and double equals. Also, a slight aside, these are part of the order of operations, believe it or not. You just never think about them because you instinctively know they're dead last, right? You have to solve both of the sides first before you can compare anything. They're just dead last on the order of operations. Okay, but here, so what we're doing here is we're saying for letter in text, if the letter is equal to A, right? We can do that equals with A. So if the letter is equal to A, total plus equals 1. And if we ran this right now, it would tell me, aha, this thing, the text you passed in, apple, sorry, I'm going to move this up here so it's easier to see. Apple has only one vowel in it, right? It has only one vowel in it. I mean, and as far as we've programmed, right, it does. Because we've only checked for A's. So why don't you go ahead and take a few minutes and think about ways to add on to this. If you know how to use the the or keyword, you can use that. Otherwise, you can think about the way to ask for other functions. Hint, hint, nudge, nudge. Other letters. Hint, hint, nudge, nudge, wink, wink. It might just be a matter of copying, pasting. Does So try that out and see what you can do. Remember, this indentation follows the same rules over here. If it's indented into the if statement, it means it's part of the if statement. So if you wanted something else after the if statement, you might want it there. There we go. All right. So, if you followed the pattern, you may have come up with an answer that looks something like this. Copy paste this a few times. A, E, I, O, U. Now some of you may be going like, technically, don't you want else's in there? Yes, but in this case, this gets the answer correct, right? Right? If it's an A, add. If it's an E, add. If it's an I, add. So it's just going to check that letter against all 5 cases. Now, so that does work. Okay? Now, there's a lot of different ways to do this. One, which is part of the reason why I bring it up. There's no, and why I bring it up so close to the test, because it demonstrates, hey, you'd get full credit for this one too. You would also get full credit for these next solutions, which are a bit more clever, right? So these if statements, as you'll learn, are called independent if statements, meaning that they fire independently of another. This one checks, and if it's true, it will go. And if the word could be if a letter could simultaneously be A and E somehow, it can't. But if it could somehow be, then it would increase by 2, right? Once for A, once for E. That doesn't happen because a letter is a letter. It can't be both A and E, right? But logically, what you're probably thinking is something like this. Elif is short for 2 things in an if statement put together, which are else if, which simply says, these are a bunch of conditions. It's got to be one thing or the other. Okay, you'll learn more about them, but This is another way of doing this. If A, else if B, else if I, else if O, else if U. Make sense? Meaning, and the advantage of this is that it's a bit more optimal, because if it's not, say we check the last letter and it's E over here. We're checking the last letter, okay? If letter is E equal to A? No, it is not. Is E equal to E? Yes, it is. What happens here is, because we're in an else if statement, it will just stop and it will go on to the next letter. But there's no next letter in this case, so we'll just straight up stop. In this situation, what we would have, which again is still correct in this context, it will say, okay, is E equal to A? No. Is E equal to E? Yes, it is. Is E equal to I? No. Is E equal to O? No, it is not. Is E equal to U? No, it is not. So it just goes through. So when you do it like this, it will go through all 5 options every single time, whereas the other way, it will stop. Another way to do this, though, is what you end up doing in most other programming languages, is rather than writing one big if statement, write 5 separate if statements, we write an or statement. It makes grammatical sense here. So if letter is equal to A, or letter equal to E, or letter equal to I, or letter equal to O, or letter, oh boy, this is a long one, equal to Q, right? So we write it like this. If it's one of these things, right? If letter's A, or if letter's E, or if it's an I, or if it's an O, or if it's a U, total plus equals 1. So all 5 of those options. Now you'll learn, there's two of these kind of grammatical statements we can have in here. The or, which means if it's one of the following, and, which is that if it's all of the following. Again, the focus on here is just to show you that there's lots of ways to do something. But to circle back around, Python has we have one other trick up our sleeves in Python, which makes our job a lot easier. Okay, so this is one other way of doing it. My personal favorite way, though, for Python is, and probably the way that you'll like the most because it's the easiest, is this. Vowels is equal to A, E, I, O, U. That's it. Okay, over there. And then we ask ourselves something very simple. If letter in vowels plus equals, total plus equal 1. Now what does this do? Well, for each letter, for every letter in the text, we're going to ask if that letter is in here, in vowels, right? Is it inside here? Just like when we did all these over here, asking if something is inside here, true, and it'll give us a true or false answer. And if it's true, we increment. And if it's false, it just doesn't do the if statement, what's inside the if statement. It goes on to the next line. So this is another way of doing that. Okay. So let's see. Even number of digits, 3-digit Armstrong number. I'm just trying to think of which one I want to do next, okay? Because we have these if statements. Because this one does a lot of if statements in there. Find function given integer as parameter returns whether or not a number is a 3-digit Armstrong number. Okay. Number of even digits. We will go ahead and do number of even digits next, okay, because that will give us a couple different ways of, because that's another problem that has a bunch of different ways of doing things, okay. So our next function is kind of a classic. I believe I include something like it always on the second exam, but not the first, right? The second exam, not the first. Which, given a number, tell me how many even digits there are in it, okay? By which I mean, and then what I always do on exams when we do functions, which is something for exam 2, not exam 1, asks, hey, here's an input and here's an output. So if your function's given the number 254, we're going to get 2 back. Why? Because 2 of the digits are even, 2 and 4, right? If the number was 123, the answer would be 1. It has 1 even digit, the 20, right? Make sense? So on exams, when I do these kind of things, you'll see something like, so if the function name is num, you'll see comments like this. Num even digits, okay, for 1. Digits. 10, 1. 1, 4, 5, 6, 4, 4, 6, 2, 6, 5. Where I just list a bunch of examples out, right? The number, and 4, 4, 6, 2, 5 gives us 4 digits. Why? Because these 4 are even, whereas this last one is not. So you'll see this a lot on exams, where I try to give you good documented input and output, expected inputs and outputs. Okay, so then I typically provide the function like this: num even, or rather the beginning of it, num even digits for some number. Okay? So here's another counting thing. Instead of counting vowels, we're counting the number of even digits. Now, our instinct here, the instinct here where you would get partial credit and you get partial credit because even though it's wrong, it shows you have some understanding of how you would tackle this problem. Okay? So this is what I commonly see wrong on some exams, okay, which is this. Okay, for x in number, 4-digit in number, and then we ask ourselves if digit is modulo 2 equal 0. What? And then, then I forgot the other bits. This is why I always like to do these first, so I don't forget them. Total is equal to 0. Total plus equals 1. A lot going on in here. Don't worry, I'm going to go all over it. Even though it's wrong, it's worth going over the logic here. Return total. Okay. So what is wrong? It is this line that is wrong, but we'll get into why it's wrong in a bit. Okay. Let's go ahead and read what we assume it would do, because that is an extremely useful operation to get to where we want to be. Okay. Number of even digits. And for context, I'd be giving these out today, essentially. Like if this was a homework, I'd be giving it out today with the assumption that you'd be solving this all, not right now, but like next week. But this is not. I'm trying to go over these things now. So 4-digit in numbers. So for every digit in the number, if the digit mod 2 equal 0. What in the world? Okay. So what does that mean? Well, the modulo operator, if you remember, big fan of it. You'll see it on the exam. You'll see basically 2 types of modulo operators, right? Or 2 times where I use the modulo operator. Possibly 3. But where do I use it? I use the modulo operator to say when we want to divide by 2. When we want the remainder of something divide by 2, and when we want the remainder of something divide by 10. Getting the remainder of something divided by 2 helps me tell whether something's even or odd. How? Well, right, if I take 123 and mod it by 2, I'm asking what's the remainder of 123 after I divide by 2? 123 divide by 2 gives me some number, like some I think it's like 61. Yes, it would give me 61 as the quotient. But it can only evenly divide 122. Can't evenly divide 123. So that's why 61 would be the quotient. That one left over is the remainder. Let's go to another example. What about 11, right? That's another easy example. 11 mod 2 gives me 1. Why? Because we can evenly divide 10. Quotient would be 5. This would give me 5, remainder 1. Okay, so modding 2 gives me that remainder. 11 divide 5, 2. Okay. The quotient, the remainder of something mod 2, the remainder of something divided by 2 is always going to be 0 or 1. When is it going to be 0? It's going to be 0 when it's even. 124 mod 2. It's even, so I get 0. Make sense? So here it's asking, hey, I'm going to take this digit, which is going to be a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Right? It's going to be one of those. And then I'm going to divide that digit by 2. And I'm going to ask what's the remainder. For 0, 2, 4, 6, and 8, that's evenly divided by 2. So the remainder is 0. If it's a 1, 3, 5, 7, or 9, one of the odd numbers, if it's an odd number, doing modulo 2 is going to get me a 1. So if it's an even number, this will be true, which means this will fire. Right? We're asking the question, is this digit mod 2 equal to 0? If it is, do this. If it's true, do this. Otherwise, do nothing else. So we're asking for each digit mod 2 equals 0 plus equals 1. So what is the issue here? I mentioned that this is incorrect code. This is not the incorrect logic. This is why partial credit would be given, because you know this part. You know how to check if something's an even digit. And then you also know how to do a running sum. And you know how to start it, and you know how to get it back to me. That's a lot. So you'd get a lot of partial credit on this one. Depending on my rubric, it'd be somewhere between, if it was a 10-point question, it'd be somewhere between 5 and 7 points if this was the answer. What's the issue? Well, this crashes. That's why. But specifically, it's why it crashes. It crashes because number of even digits in 1,000, print. We get an error on the line that I said, 4-digit in numbers. Type error. Int object is not iterable, right? So this is getting, what am I tying back to? It's where you can use your for loops. Where can you use your for loops? You can use your for loops on ranges or collections. Range is technically a collection, or a sequence. So ranges or sequences. What do I mean? In other words, in this class, you're going to when you use a for loop, it's going to be for thing in, and the thing on the right side of the in is going to be either a string, a list, or a range. Okay? Now, I want to go through each of these digits individually. So when students, if they're on their computer and trying this, they'll be like, well, range, if I went range to the number, that would give me all the numbers from 0 up to that number, so that's not what I want. However, if number was instead a string, I could iterate over it. And so we get this weird, but working solution. This is what typically I get from most students. It's weird. I don't like it, but it works. And it doesn't matter what I like or not, as long as it works. Okay? So it might be something like this. Number string is equal to str number. So there what we've done is that we've turned this number into a string. Okay? And now I can iterate over it. 4-digit in number string. Okay? Which leads to the next thing that we have to do, is that it's like, well, we can go through each digit individually, But now each digit is a string, right? And you can't modulo a string. So we've taken a number, we've converted it into a string, and now what we're going to do is we're going to do this silly thing where we say digit is equal to int digit, where we just take that digit and we convert it back into, we take the string and convert it back into an integer. So here, right, in order to iterate over it, we turned it into a string, and then in order to work with the string in a numerical form, we do this. The other way that you would do that is you could do an if-else statement. If digit is equal to 1, right, you could say if it's this, sorry, if it's a 0, if it's a 2, if it's a 4, just like we did above, right? We could do what we just did over here, only if, you use 0, 2, 4, 6, or 8. So this is one solution. This is the solution that most students come up with. And as I've mentioned, it's not a solution I'm happy with because it involves conversions, and conversions like that can be wasteful. Okay? The preferred solution I have, which I'll make another one, and I'm just going to call it num-even digits 2, is this, which involves using the while loop, which hopefully you've seen a bit of, right? We saw a little bit of it. Hopefully you've had the chance to look at the textbook and done the readings, but if you haven't, it's like a if loop. It's like an if statement, only it repeats. Again, for loop, the exam that you're planning on doing this next week doesn't touch if statements, doesn't touch while loops. Why am I doing them anyway? Because we're building muscles essentially here. We're doing practice. Any kind of pushing, any kind of discomfort in the class will make you that much better of a programmer on the exam. Okay? So total is equal to 0. Return total. We know this part, right? Set up the thing I want to return, get the return in, and then I'm going to do what I need to do in the middle. And what I'm going to do now is I'm going to say while number is greater than 0. What in the world? So I'm going to show you the answer that I had come up with, and then I'm going to explain it. But what I'm going to do is I'm going to start out with number, and what I plan on doing is I plan on looking at each individual digit in the ones place. What I'm going to do is I'm going to start by looking out at this digit, and I'm going to look at the tens place, then I'm going to look at the hundreds place, then I'm going to look at the thousands place. Okay? Why? Because I can easily manipulate those two things using division and modulo. Okay? While number is greater than 0, what I'm going to do is I'm going to get the last digit of number by saying number mod 10. When you divide something by 10, the ones place is going to be the remainder. Right? That's the wonderful property of that. Right? So if I do 1, 2, 3, 4 mod 10, it's going to give me 4. If I do 1, 2, 3, 7 mod 10, I'm going to get 7. It's a wonderful property here. Why? Because, again, quotient asks what's the remainder. What's the remainder after I divide by 10? It's going to be what's in the ones place. So I get what's in the ones place. Okay? And I can work with that. Okay? So then I can ask myself the same question we were asking earlier. If digit is mod 2 equals 0, if it's even, total plus equals 1. Right? We're going to increase total by 1. Now, how do I move on to now I'm done with the ones digit. So what I'm going to do is I'm going to move on to the next digit for the next statement of loop, which is I'm going to say this. Number is equal to number divide 10. So this operation So I've actually alluded to this back when I talked all the way back in lecture 3 about this, where moduloing by 10 gets you the last digit. This operation, dividing by 10, using the integer division, throws away the last digit. All right? 1, 2, 3, 4, divide by 10. 1, 2, 3, 7, divide by 10. Why? Because the quotient is 123 in both cases. The remainder was 4 or 7, but the quotients would be the same. Doesn't matter what the last digit was. Right? It gives you everything but the ones place. Then I take that and store that. And as long as there's still numbers to count, great. I'll do that. Now there's a couple edge cases like negative numbers and 0 where this doesn't necessarily work, but we're not testing negative numbers, and I want to get on to the next question. So run it. Of course, it's going to print out 3 from the previous one because that's what I'm testing. So let's go ahead and try doing this. Print num even digits 2. We'll give it 1, 2, 3, 4, 5, 6, which should give me 3. Oh, and sorry. We're using Python 3, which is actually did something extremely radical a while ago, which is that Python 3, they looked at Python 2 and they went, these are parts of the language we don't like, and so they made Python 3 reverse incompatible with Python 2. That used to be a huge deal. But Python 3 was just that much better. So, and this was one of the things, and this used to be the way you could print things in Python 3. Sorry, in Python 2. Can't do that anymore. Just because they want to make sure you understand print is a function. So that's why you see me sometimes forget to do that, because I learned in Python 2. And Python 3 really is that much better. Okay. All right. Now, this last one came from a Java textbook. I'm still very partial to it. I'm skipping number 3, going straight to 4. This one's very nice. I like this one because it's actually giving us an objective here. This one does not take an input in, and it's going to print something out. So we don't need to worry about the printing in or out. Okay? And this one was in the vein of a Batman thing. So Holy Digits Batman. The Riddler is planning his next caper somewhere on Pennsylvania Avenue. In his usual sporting fashion, he has left the address in the form of a puzzle. The address on Pennsylvania is a 4-digit number with the following properties. All 4 digits are different. The digit in the thousands place is 3 times the digits in the tens place. The number is odd, and the sum of the digits is 27. Now, the only way without a computer to do this is to do it the same way a computer would do it, which is go through all the numbers in that and basically cross off all the ones that don't match until you're just left with 1. Right? So write a function that uses a loop or loops that returns the address where the Riddler plans to strike. So first off, we're going to start off by just kind of looking at this puzzle. Okay? First off, we know it's a 4-digit number. Okay? It says so in the problem definition. It's a 4-digit number. That means the answer is somewhere between 1,000 to 10,000 inclusive. Right? Sorry, 1,000 to 9,999 inclusive, which means this. Okay? Def Riddler doesn't take in anything. It's going to be 4 x in range, where x is some number. It's our address. It's going to somewhere from 1,000, right, up to but not including 10,000, right? It's a 4-digit number, so we go up to but do not include 10,000, right? So, make sense so far? Right, it's a 4-digit number. This goes through all 4-digit numbers, right? So let's go ahead and look at the next part. So all 4 digits are different. Okay, we'll get. We're gonna just go through these and see which ones I can address right now. All 4 digits are different. The digit in the thousands place is 3 times the digit in the tens place. The number is odd, and the sum of the digits is 27. So now we could do, now that then point 3 is actually probably the easiest thing to address. We could do it in one of 2 ways. We could write an if statement, ask something like this: if x if x mod 2 equals 1. This is not what I'm doing though. Okay, we could ask this, or we could be a bit clever about it and instead modify the for loop so that we only check even numbers with the for loop. We only generate even numbers with the for loop, right? Instead, what I'm going to do is I'm going to say we're going to start at, since it's going to not needs to be an odd number, instead of starting at 1,000, I'm going to start at 1,001, right? It's got to be a 4-digit odd number. And now to make sure, so this goes from 1001 to 9999 inclusive, right? Up to, but not including 10,000. And so I'm going to put in that third argument we rarely use, but is very useful when we can, which is to put a 2 there, which says that we are going to go up by 2s, right? Just to go through that, we're going to print out x to just kind of show all the possibilities, right? Oh, it didn't run. Why didn't it run? Because I didn't call it. I didn't invoke the function, right? When you create, if you haven't picked up on it, right, because I didn't explicitly say this, when we write a verb, right, when we write a new verb, a new function in this, you can't just run it. As far as this is concerned, this is actually like a variable name, right? If I actually print this out, if I actually print out Riddler, like just this, the name, if I ask it, it's going to say it's a function called Riddler, and here's its location in memory. Okay, now why does it do that? Because this is just simply the name of a function, and being able to access the name of the function is sometimes useful in a very high-level way. But this is basically us talking about the word. This is us talking about an action rather than doing the action itself. In order to do it, you invoke it, which I have always liked because it sounds like we're doing magic. It's a very magic-sounding word, invoke. So to invoke a function, that's where you use the parentheses to say do the verb. And so here it goes. I'm going to go ahead and cancel as it's going because it's going to be otherwise abominably long. But here you can see 1443, 1445, 1447. It is not hitting any of, it's going up by 2s. Right? If without this, right, it'd start at 1001 and then be going up by 1s, right? So with the 2, it's going up by 2s. Okay. So now since that is done, let's go ahead and go through the rest in order. All 4 digits are different. That means we're going to have to get all 4 digits of this number. Okay? We're going to individually extract all 4 of those digits. Now we could you could do something like this, where you could say string of x, right, where we turn x into a string like we used to, right? And then I could say something like the thousands place is equal to, x 0, okay, int x0, and then the hundreds place is equal to, or hund is int x2, but that's not x2, x1, right? But that's not how I typically do this problem, but it is a valid solution. Okay? But the long and short of it is, however we calculate the thousands place, the hundreds place. Why am I calling it thou and hund? Because tens, ones, now they're all four letters long, which is useful and looks nice. Right? However we calculate this, okay, the next question, what we're going to do is we're going to check all these against each other to make sure that they're not equal. Okay, so we'll do something like this. If ones is not equal to, so how do I say not, so this is equal to check if two things are the same. To check if two things are different, we do not equals. Yes?
Shouldn't we add these four together and be like if this does is equal to 27?
Yeah, you can do that in any order. You can do that in any order. But right now I'm just doing this. If ones is not equal to tens and ones, because they all have to be different. And ones is not equal to huns, dot, dot, dot. We'll write the rest out in a bit. Okay? Keep the printx out over here. So our goal for you in the next few minutes is I want you to think about how in the world do we get the thousands place, the hundreds place, the tens place, and the ones place out of this, out of a 4-digit number. How do you do that? This was normally the pain point for my students when I've given this as a homework assignment. And to give you a hint, we kind of looked at it a bit in the last problem, where I told you about these two operations. To get the last digit of a number, you mod by 10. And to get rid of a number, and to get rid of the last digit, you divide by 10. Make sense? So you could use those two things in conjunction with each other, possibly more than once, or more than one, to get all these. So think about that for a second, just using manipulations. If you need to, test out your theories by doing like 1, 2, 3, 4, and then whatever operations you need to on that one, right? Like this. Oh, if I do 1, 2, 3, 4 divide by 100, that gives me 12, right? So if I could go through there to get, how could I use that possibly to get the hundreds place, which would be the 2. So think about that for a second. So more than a second, a few minutes. How do I extract these digits? All right, so I'm not going to go through it all yet. I'm hearing good discussion, but in case you need to be jump-started on this, right, to get the ones place, that's as simple as doing this, right, using modulo 10. To get the tens place, we can use x divide by 10, which would give us, right, if it was 1, 2, 3, 4, this would give us 1, 2, 3. And so that 3 is the tens place. So all we would have to do is we'd have a new 3-digit number, and we just want the last digit of that. So you don't need the parentheses. I just figured the parentheses would be more clear. So continue on. When we keep talking, that wasn't me trying to say don't talk. All right. So let's go ahead and finish off this problem. So, the thousands place is actually fairly straightforward to do. Right? We just need to get rid of the 3 digits in the end. So get rid of the ones place, then get rid of the tens place, then get rid of the hundreds place, which is just a long and winded way of writing this out. Divide by 1,000. Right? So both of those methods work, by the way. Again, I don't care which one you use. If you get to a right answer, I'm happy. Okay? This is not the class where we talk about efficiency, right? We start talking about that in the 3rd class and really care about that in the 4th class for computer science. Here, we just want solutions. Okay? So, now this one is probably the trickiest. We want to get x, we want to get rid of the last 2 digits. We want to get rid of the ones place, get rid of the tens place. Another way of doing this. So this would give us, if we had 1, 2, 3, 4, this would give us 12. Mod 10 to get that 2 in the 12. So there you go. So now the rest of this is unfortunately a bit of an annoyance. If ones is not here, we got to make sure they're not equal to each other. So first, if the ones is not the same as the tens, and the ones is not equal to the hundreds, and the ones is not equal to the thousands, and the tens not equal to the hundreds. I don't need to write tens not equal to ones, by the way, because it's reflexive. If the ones are not equal to the tens, then the tens are not equal to 1, right? The ones place are not equal to tens place. I don't have to check if the tens place are equal to 1. It's fine. So I only have to do that once. Okay. Next. Tens, ones. And tens not equal to the thousands place, and now the huns not equal to the thousands place. And that's it. That checks all the possible combinations, by the way. The ones against the other 3, the tens against the hundreds and thousands, and then the hundreds against the thousands. So if we do this, this gets, huns, did I mean hund? Yes, I did mean hund, not huns. And there we go. We got a lot more. So that's a lot more where they aren't equal. So let's go ahead and work on another one. So we could make this one big and statement, but it's already terrible to read because it's just so long. So I'm just going to do another if statement nested in it. So if this is true and if this is true. So what are the other 2 conditions? The digit in the thousands place is 3 times the digits in the 10 place. So if the digits in the thousands place is equal to 3 times the digits in the tens place. And we can check that in the answers we are getting now, where we can see that 9 is 3 times 3, 3 is 3 times 1, and 6 is 3 times 2, right? The digit in the thousands place is 3 times the digits in the tens place. Right? And the last one says the sum of the digits is 27. So we only want to print it out if this is true, and then this is true, and then if thou plus hund plus tens plus ones is equal to 27. So there we go. We get only one possible answer. It's odd. It's 4 digits long. The numbers are different. 9, 8, 3, 7. This is 3 times this. And then 3 times, then is it equal to 27? Well, 3 plus 7 is 10. 9 plus 8 is 17. 17 plus 10, 27. So there you go. Now, what I'm going to do is I'm going to take this, all right, and now I'm going to drop this on Discord. So let's see if I can't do this. Dot, 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 Py. Is it Python 3? Forget how to edit this so that it's formatted correctly. Oh, there it is. All I have to do is just hit right. I just have to say Python. Now if you look at it again in the Discord channel, you'll see that it's actually very nice. All right, have a nice day. I'm going to work on uploading this.